I have here a liquid propane gas cylinder. When full, this cylinder will contain 4.5 kilograms of gas. Such gas bottles are commonly used for barbecues or in caravans and travel trailers. In my case, this is a gas bottle I removed from my caravan travel trailer. After we've used a gas bottle several times, it's useful to know how much gas is left in there. And there are different products which use different technologies to do that. Some of these products are more effective than others. I have here a very cheap magnetic temperature sensing gas level checker. And here this product is the TRUMA level checker, which uses ultrasonic technology. In this video, I will demonstrate the use of these two products on this gas cylinder, and I'll also explain the limitations of this temperature sensing level checker. And to do that, I will use my industrial grade FLIR E8 thermal camera. So join me in this video as I carry out this demonstration. This is the liquid propane gas cylinder I just removed from my caravan travel trailer. It has been used for cooking for several times, so I know that the cylinder is definitely not full, but it's not empty as well. Let's start with the simplest gas level indicator, and it is this magnetic indicator which uses a temperature sensor backing. On the back, the instructions say to apply the indicator near the bottom of the tank below the middle weld line. So that's the middle weld line. It wants me to place it at this part here. Then, importantly, it says turn on the gas. This indicator only works when the gas is on, and I'll explain why. And to wait 2 to 5 minutes after using the gas. Then to read the level, when the tank is full, the gas level is above the indicator and no level will be shown. When the gas level falls within the range of the indicator, the color will change in at least one of the bars shown on the right. If more than one bar changes, a level is shown where the leftmost bar is indicating. When the level reaches the bottom, refill the tank. Extreme temperatures below freezing or above 100 degrees Fahrenheit may affect the accuracy of this indicator. This is what it looks like. If the light changes at the bottommost LED, it means it's time to refill. If the light changes at this portion, it means it's almost empty. If the light changes at this part, it says it's full, but that's not really true. So place the magnetic indicator strip here below the weld line. I have left the magnetic strip on the gas cylinder for about 5 minutes. There is no change in the LEDs from the temperature sensor. So there is a rectangular matrix of LEDs of different colors. Each horizontal LED strip contains several LEDs of different colors, and what would happen is for each row of LEDs, depending on the temperature sensed at that row, the relevant LED color will light up. In this case, going from top to bottom, all the rows of LED are essentially the same color. This indicator only works if this gas cylinder is connected to equipment such as a barbecue or cooktop stove, and the stove is actually using the gas. Let's assume that the liquefied LPG is at this level. What will happen is that when the gas bottle is used, the surface layer of the liquefied portion of the LPG will vaporize and escape out through the valve. To turn into vapor, it needs energy. So it would absorb energy through the steel cylinder walls. Because the liquefied portion of the gas at the bottom is better able at conducting heat than the vaporized portion of the gas, this bottom liquefied portion of the gas cylinder will extract heat from the environment, and so it would feel colder to the touch because its temperature would be colder than the upper portion of the cylinder. In that case, the LED lights from this portion down would show a colder temperature compared to the higher portion of the LED lights, which would show a warmer temperature. And that's how this indicator tells the level of liquefied gas remaining. This would mean that if the level of liquefied gas was up here, then placing the indicator here would not show any temperature differential. So I would then have to place the indicator here to get a temperature differential across here. But as you can see, because I'm not using the gas cylinder for cooking, therefore the cylinder does not exhibit any temperature differential. To prove that there is no temperature differential in the cylinder wall across the length of the cylinder, and that's why this temperature sensing indicator will not work, I've stuck a black electrical tape along the length of the cylinder to enable accurate measurement of the temperature across the length. I have here an industrial grade FLIR E8 thermal camera. It has a measuring circle which measures the temperature to 0.1 degrees Celsius. I'm now aiming at the top of the black electrical tape, and the temperature is approximately 18.9 degrees, 18.7 degrees, 19.2 degrees, 18.9 degrees. I will move the aiming point to the middle where the horizontal weld is. It is reading 18.4 degrees, 18.7 degrees, 18.8 degrees. I move the aiming point to the bottom of the black tape. It is 18.2 degrees. 18.7 degrees, 18.4 degrees, 18.7 degrees. So this shows me temperature difference from the top to the bottom of the cylinder wall is only decimal place temperature difference. And I guess sub 1 degree temperature difference is not enough to trigger the sensitivity in this crude gas level indicator. So it will not work. We next test the TRUMA gas level checker. TRUMA is a company based in Europe. Let's unbox this. On the back of the packaging, there's instructions on its use. It says it's a level indicator with integrated LED flashlight for steel and aluminum gas cylinders, propane, butane, LPG, with a diameter of 7.9 to 13.8 inch, which is 200 to 350 millimeters. It reliably measures the filling level using ultrasound with a color LED indicating the filling height. This product is made in Germany. This is the user manual. Here is the TRUMA gas level checker. It has a button here to turn on the LED light at the front. This black rubber cap in front is depressed when I push the instrument against the gas cylinder wall. The device uses a 9-volt E-block battery. Its weight, including battery, is 100 grams. It is capable of operating in ambient temperatures of minus 15 degrees Celsius to positive 40 degrees Celsius. It is not suitable for plastic cylinders and is also not suitable for gas cylinders which have internal components. To use the device, hold it at 90 degrees to the steel wall, so not at an angle like this or like that. To use it, push the device at 90 degrees into the steel wall, and it will make a beeping sound and flash orange whilst reading. That was very quick. The orange was one flash and a beep, and then it turned red. And red indicates that at that level, there is no liquefied gas. Retract it, bring it lower, and check at the next level. Push in. Again, there was a quick one flash of orange, one beep, and then the red light again, indicating again no liquefied gas at this level. Same thing, no liquefied gas at this level. No liquefied gas at this level. Let me bring it back right to the bottom. One quick flash of the orange light and a beep. Then it turned green, indicating at this level there's liquefied gas. Let me go upwards. That's empty. That's empty. That level has liquefied gas, so it looks like I should really refill this cylinder because it is just about empty. So I do find this useful. It gives me a level of certainty of how much liquefied gas remains in the cylinder. I do like this instrument. It certainly performs better than the simple crude temperature sensing magnetic strip. I'll test it one more time against this white paper masking tape. Green, green, it seems that if I try and measure it against the white paper masking tape, it becomes inaccurate. The level difference between here, indicated on the masking tape, versus here, without the masking tape but straight against the steel. So there you go. Pull this away. And if I test it now, red. Yep, that's much more accurate. That is about the level of the remaining liquefied gas. So I should get this gas bottle refilled. I'm glad I used the TRUMA gas level checker on this gas cylinder because I have a camping trip coming up, and initially I thought this had adequate gas remaining, but no, it looks like I will need to have this cylinder refilled. I hope you found this video useful and interesting. Do hit the like button and subscribe to my channel for more and help the channel grow. Thank you so much.